Okay, I didn't do it last night because I was at a party, but now I'm going to catch up and do the coding from yesterday. So let's just make sure this is streaming. I hate you, YouTube Studio Beta, and let's go to live streaming, and let's go here, and there we are. Okay, good. So, um, day 22. There's not much to do with the doors of relatively straight within our dice enterprise new card shelf you've been working on. Either shift storage find deck space cards. Looking at space cards, there are 1007 numbered 0 to 1006. Deck must be either still in factory order with 0 on the top, then 1 all the way through 1006 on the bottom. Practicing 3 different techniques to use while shuffling. So your deck of only 10 cards. Deal into new stack. Create a new stack card and the top card of the deck onto the top of the new stack repeatedly. Okay, so finally pick it. So deal into the new stack is just reverse. To cut end cards, take the top end cards off the top of the deck and move them as a single unit. The bottom of the deck retain their order. Okay, so that's pretty good. Version seek where n is negative. In this case, cut the absolute value of end cards from the bottom of the deck. For example, to cut -4. That's fine. To deal with increment n, start by clearing enough space on your table to lay out all the cards individually along the line. Deal the top card, then move n positions to the right. Deal the next card there. If you would like to move a position past the end of the space rather than keep counting, this process until you run out of cards. For example, to deal with increment 3, keep going. Move right 3 and deal. Position on the table which already contain cards still counted. They're not skipped for this technique carefully designed, so never put 2 cards same position or leave a positions on the table which already contain cards. Are still counted. Finally collect the cards on the table so that the leftmost card ends up at the top of your deck, cards right ends up, so the rightmost card is at the bottom of the deck. Each process is applying many of these techniques. Here's some examples going to take the rest factory order. The new stack. Okay, this seems relatively straightforward. Day 22.text. Let's do this. And certainly in part 2, from typing import. In part 2, they're going to make it so that my brute force way from part 1 doesn't work, but that's fine. Deck is a list of ints. And let us go and say, so we have 3 to deal into new stack. So reversed equal reversed 1, 2, 3. Yeah. Def deal into new stack. Deck. Return list of reversed deck. So that's fine. Def cut deck. And let's say n int deck. Let's say num cards equals len deck, and let me just make sure that if n is negative, so let's say I have -6 mod 10, that'll be 4, so that's good. N equals n mod num cards, that will deal with negative, so negative, and cut in cards, take the top, so return deck n to the end plus deck up to n. And then finally we have cut -4, that'll turn to 6, so I take the 6, blah, blah. Finally to deal with increment n. So def with increment deck n int goes to deck. And so on and so forth. So and let's say result equals, we'll just copy it, and then position equals 0 for card in deck. And let me just make sure I have this right. Deal the top card in the current position, move the current position right 3. Okay, so and let's say num cards equals len of deck. For card in deck, result pause equals card, and pause equals pause plus n mod num cards, and then return deck. And so let's write a couple of tests just for this. So assert that deal into new stack of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9 equals 9, 8, 7, 6, 5, 4, 3, 2, 1. And assert that, and actually let me say test deck equals this, because we're not mutating it, so I can just use the same one each time. Test deck equals that, and then cut test deck, comma 6 equals, and so we said that should be 6, 7, 8, 9, 0, 1, 2, 3, 4, 5, 6. And then similarly, if I cut it at -4, that should be the same. And finally, assert that with increment test deck 3 equals, and let's just see what they got it. This and I need to put some commas in here. And I'm already thinking ahead about how I'm going to do this more quickly in part 2, which I probably need to do. So let's run it. Day 22, assertion error. Okay, so teal, that one's surprising. Because I left off the 0. Okay, so that's not that surprising. Okay, test deck, comma 6, 6, 7, 8, 9, 0, and I put an extra 6 on the end. So again, not very good at writing unit tests. And this should be -4. Okay, so every one of my tests I wrote wrong, which is good. And finally, with increment test deck, comma 3. Okay, well that one is extremely wrong, and that's because I need to return the results. And okay, good. So now and we're saying deck is 1,007 cards. So now let's say deck equals range 1,007, and with open day22.text as f for line in f. If line.strip equals deal into new stack, deck equals deal into new stack deck. Otherwise, if line let me do line equals line dot strip. If line equals deal into new stack, elif line starts with cut starts with n equals line dot split -1 and int, and dec equals cut dec n. Elif line dot starts with deal with increments. And again, I can do this and say dec equals deal equals with increment dec n, and then what does it want me to return? It wants me to return what is the position of card 2019. Okay, well, let's just do this. Range object dec dec.index of 2019 is 1867. That's the right answer. Continue to part 2. Probably users who will improve much more. Yes, every 3D printer makes you some cars with you train ship repairs. Blah blah blah. You have a giant brand new factory order deck of this many space cards. You decide to the deck this many times in a row. To apply your complete shuffle process to the deck this many times in a row. You need to be careful. One wrong move and you might overflow your entire ship. For shuffling, what is the name on the card? The position 2020. Okay, so now we're gonna have to be more clever, like I figured, although I didn't figure. So let me, so let's think about this, and I'm going to make a new file because I'm going to mess everything up. Day22 part 2.py, put it in. Okay, so now we want to, what number is on the card that ends up in position 2020? Okay, so now we're going to focus on what card is in position 2020. And complete shuffle process this many times in a row. Okay, and this many cards. So like that's too many to do things with. So we need to think about it. And let's think about it. Let's go backwards because I think going backwards will be more exciting. So let's try that. So going backwards. So def deal into new stack. So let's think about this. So like if I do cut 2175, this is at position minus, then I get the one at that many before. Deal with increment 62. I can figure out what position it's coming from, 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 what position it's coming from. So let me approach it that way. Target, and let's say num cards equals this. Okay. Target int equals, I was going to just do that. Return the location of the card that ends up at targets. Num cards int equals num cards. And so dealing a new stack is just reverse. So I just want to return num cards minus targets minus 1, because if target is 0, I'm going to get the last card, which will be at position num cards minus 1. If I want card 1, so assert the deal into new stack. If I want to get card 3 and num cards equals 10, then 1, 2, 3, 4, 5, 6, 7, 8, 9 goes to not 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. And so at position 3, I'm going to get 6, which is 10 minus 3 minus 1. Okay, so let's run day 22 part. And I still don't know how I'm going to solve the many, many times, but I'm going to look for a cycle. And that's, okay. And so that's that. And now again, if I cut target int n int num cards int equals num cards. And so let's think about this now. Return the location of the card that ends up at target. Okay, and so let's just say n equals n mod num cards again, so that it's a positive number. And so what happens is cards n plus cards n plus 1 dot 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 num cards minus 1 0 1 2 3 4 dot 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 n minus 1. So it looks like that, right? And so in other words, we get num cards minus n and n. So we split like that. So if target is less than or equal to num cards minus n, then I want to return n plus targets. right? So if target is 0, I'm going to get card N. If target is 1, I'm going to get card N plus 1. Otherwise, I get N. Otherwise, I get target minus num cards minus N. So I think that's right. So so again, let's write a test for this and say if I cut at 4, then I'm going to get 0, 1, 2, 3, 4, 5, and 6, 7, 8, 9. So let me just look at the definition of cut. To cut n cards, take the top 10 cards and move into the single unit at the bottom of the deck in their order. So, right. So if I cut 4, no. So to cut 4, I did this totally wrong. I do this. And so what that means is that, let's say I want to know, and this is in position, let's see, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So assert that cut for n equals 4, num cards equals 10 equals 8. Assert that cut 6, n equals 4, num cards equals 10 equals 0. Assert that cut 7, n equals 4, num cards equals 10 equals 1. And let's just run these tests and make sure that cut 6, n equals 4, num cards equals 10. That gives me 10, which is wrong. So let's figure out why that is. So num cards minus n. So if targets is, so this should be a less than. Otherwise, so target is 6. Num cards minus n is 6. So that's not right. Otherwise, I return targets minus it's interesting. Six less 10 minus 4, that's false. No. So target equals 6. N equals 4. Num cards equals 10. Num cards minus oh, stupid. This should be num cards, not the global constant one. No wonder that's causing me a problem. Num cards and num cards. Okay. Okay. Good. So that's good. And now here's the hard part, which is the with increment. So with increment, and I'm going to get a target, which is an int, an n, which is an int, and a num cards, which is an int equals num cards. And so now let's think about this. X goes to x times n mod num cards, okay? And because of what we've decided that n and num cards have to be relatively prime. Otherwise, you would not cover everything. And so what that means is, so for example, if num cards equals 10 and n equals 3, 6 goes to, 0 goes to 0. 6 goes to 18 mod 3 equals 8. Okay? And 3 goes to 3 times 3, which is 9. 7 goes to 7 goes to 21 mod 3. Sorry, 18 mod 10. 21 mod 10 equals 1, and so on. And so what that means is that need to find x such that x times n mod num cards equals targets. Okay, and so I need to find the multiplicative inverse, or in other words, such that x times n equals targets, mod num cards. And so let me, it's been a long time since I did my abstract algebra, so finite field find multiplicative inverse. Multiplying a by every number of parts is 1, brute force, since blah, blah, blah. Since the non-zero elements, just the inverse extended Euclidean algorithm. Oh, this seems like a pain in the butt. Okay, so let's look at, let's try and understand this number, because maybe this number is a power of something. Cards, mod 3 is 2, mod 7 is 5, mod 11 is, okay, so it's not anything obvious. So, and obviously I don't want to brute force all the things. So, invert elements and first use algorithm is followed. R goes to P to the M minus 1 divided by P minus 1. Compute A, R, no. Yeah, so that's not going to help. And equals target modulo number of cards. Yeah, so that's going to be really hard. So let me think if there's a different way to do this. So in other words, to get from 1 back to 7, I need to know that the multiplicative inverse of, oh, I need the multiplicative inverse of each of those things. So, so let's not do it that way, because these increments are all pretty small, right? So I'm just going to brute force this, I think. Actually, okay, so I'm going to brute force this and going to brute force. And so what I'm going to do is I'm going to say while target is bigger than 0, so no. What's going to happen is 1 goes to 3, 2 goes to 6, 3 goes to 9, 4 goes to 2, 5 goes to 5, 6, and so on. Going to brute force. And so what do I mean when I say I'm going to brute force? What I mean is that each pass goes no. What am I saying? I'm saying that I take a pass through, and I know that so if target mod n equals 0, return target divided by n. So if, I want to get to 9 and n is 3, I just divide by that. Otherwise, So what I want to do is to say while target mod n is bigger than 0. So let's say my target is 5. Um, um, so I want to say, I can take off 3 and get to, and let's say result equals 0, well, target, and then let's say result plus equals target divided by n, return results. And so we'll do this, then we'll optimize it. Well, target mod n is, let's import math. Um, let's say m equals math dot ceiling of targets divided, no, of num cards divided by targets. And so I say, how many of these can I take out? Int math dot ceil. Result plus equals m times not divided by target divided by n. Result plus equals m target minus equals no, I'm really confused myself here. So here, num cards equals 10. So this is 4 copies of, so let's say target equals 5, n equals 3, num cards equals 10. I can get 4 copies of n. Equals 12 cards. And equals 2. So let's go to 2. Cards to eat equals m time. So result plus or equal to n, target minus equal cards to eat. And then finally result plus equals return result. So again, let's try all these. Assert with increment target is 0, n equals 0, num cards equals 10 equals 0. Okay, so let's run this. N is not 0. N is 3. So let's run this. And now let's do all these. So 1, 7 goes to 1, so this should be 7, and 2 comes from 4, 3 comes from 1, 4 comes from 8, because that'd be 24, 5 comes from 5, because that'd be 15, 6 comes from 2. So let's okay. Okay, so print result target mn. So why did I get an infinite loop here? I got in an infinite loop because target is negative. If target is less than 0, let's say break and 0, 1, 3, 3. So I want to get 1. I'll target mod n. Target equals target minus cards to eat mod num cards. Let me try that now. Okay, good. And so that was the issue. I can do that. And let's do 7, 8, 9. So to get to 7, I'll get 27, which is 9. To get to 8, I'll do 18, which is 6. And to get to 9, I'll do 3. So this works. And now let's make it more efficient because it's doing the same thing over and over again. And so what I'm doing is basically saying while I'm not divisible by n, chew up this much of the target. So in other words, let's say how many times do I have to subtract off cards to eat to get something divisible by n? And so I imported math. So let's say GCD equals, oh, I don't want to use GCD quite yet. So I don't want to actually do this because it's going to take too many times. So I need to figure out how to do this all in one step, which is going to be So find k such that result plus k times cards to eat equals 0 mod n. And or so that k times cards to eat equals minus results mod n. Or so that that doesn't help me. So here's the idea. If I could figure this out, then I would just look for a cycle and then mod out that cycle. But I'm having a lot of trouble figuring this out because this is going to be way too slow. And it's going to involve some number theory, which I used to know and which I don't know anymore. So actually, I think I did want to have that. K times cards to eat equals minus results mod n. I'll just say n minus results. And then the n's here are not huge. In fact, they're all less than 100. So so let me do this. Def find k cards to eat, which is an int, n, which is an int, result, which is an int, and it's going to int. So for I in range 1 n plus 1, if cards to eat, let me do k. Cards to eat times k plus results mod n equals 0, I return k, and so assert that find k of cards to eat, which is 12 in my examples, and n is 1, no, n is 3, and result is 1. So that should just be 0, right? No, sorry, result equals 0 should be 0. And for result equals 1, that's going to be, result is 1. If I multiply 12 times 1 plus 1 is 13. That's not 0. 12 times 2, 24 plus 1 mod 3 is not 0. 12 times 3 is 36 plus 1. That's never going to work because cards to eat is a multiple of n. So of course this is never going to work. So I'm being stupid. So let's think about this harder. How many times do I have to subtract off cards to eat to get something divisible by n? But cards to eat is divisible by n. So if I have 1 and I subtract off 12, that's minus 11, which is still 1. Of course, it's still going to be 1. So I'm thinking about this wrong. So what I should really be thinking is how many times do I have to add num cards to get something divisible by n? Find k such that, so I don't need this cards to eat, that was wrong. Result plus k times num cards equals 0 mod n. Okay, so instead of cards to eat, I'm just going to change this to num cards, and num cards equals 10, and again num cards equals 10. So now to get 1, I need to go through 10 cards twice. Oh, whoops. Let me do this. That's better. Okay. And so, okay, good. So now I have this find k. So instead what I'm going to do, so I don't need this cards. I don't need any of this. And so k equals find k num cards n targets. And so I need to go okay, so now what I've done is I've said, let's say I need to get position 1. I say k is 2, which means I add that many. So return k times num cards plus targets divided by n. So let me see if that actually works. It does work well. Okay, good. So And I have all these unit tests, so that makes sense. Okay, good. So, okay, so now num cards, and here's num shuffles. So let's do num shuffles equals this. And let's say with open day22.text as f, lines equals line.strip for line in f. So that's good. And let's say def apply target, which is int, num cards, which int equals num cards. Let's call this shuffle. For line in lines. If line equals that, target equals deal into new stack target num cards. Otherwise, if line starts with cut, target equals cut target and cards. Otherwise, it starts with this. Target equals with increment target and num cards, and then return target. So let's run this. Shuffle 2019, shuffle 2000, and then shuffle the results. Okay. Scene equals this. No, scene equals target. For I. Scene equals this. Num shuffles equals 0. While target equals what's the target that we want? 2020. Okay. So target equals 2020. All target not in scene. Scene dot add target. Print num shuffles target. Target equals shuffle target num shuffles plus equals 1. So let's run this and see what happens. Scene equals set. So what I want to do is I'm hopeful that I will find a repeat in here somehow. And maybe that's dumb of me to hope that, but right, it's almost certainly dumb of me to hope that. So if num shuffles mod 10,000 equals 0, I won't print very often because printing is slow. So I was hopeful that this would find a cycle, but it doesn't look like it's going to find a cycle. So now we got to look at this more carefully and try and see if there's a way I can represent this whole thing. Nope. All right, it's been an hour. I'm gonna take a break, and by take a break I mean give up and quit. So uh, I gave it a good try, but that's as much time as I feel like devoting to this problem. So that's all.